Okay, so let's do these two, also from section 10.6. But now what's happening is we have two secants that are intersecting outside the circle. Do you see it? And even over here, it's outside the circle, okay? If that's the case, it's another fun little formula, which I like to call outside times the whole equals outside times the whole. What I mean by that is, let's look at number 3. Outside is 6. The whole thing is 6 plus 9. The outside of this one is 5. The whole thing is 5 plus x. All right, so let's write that out. We have outside times the whole, that's 15. 6 plus 9 equals outside times the whole, 5 plus x. You see it? One more time. 6 times the whole thing, 6 plus 9, 15, equals 5 times the whole thing, 5 plus x. All right, maybe I'll write it outside times the whole equals outside times the whole. Okay? And so then we just finish solving. 6 times 15 is 90. Go ahead and distribute that 5 in. You get 25 plus 5x. We're going to subtract 25 from both sides. All right, 65 equals 5x. Divide by 5, divide by 5, and x equals 13. All right, great job. Now what I'm going to do for the second one is I'm going to erase all that, and I'm actually going to delete this picture for a moment. All right, because we're going to need a whole lot of space here. It's the same procedure. We still have two secants intersecting outside, the circle. And so this is going to be, again, outside times the whole equals outside times the whole. All right, so check this out. What we're going to have is 3 times 3 plus x plus 2. Do you see it? Outside is 3 times the whole, 3 plus x plus 2. And that's going to equal outside x plus 1 times the whole, x plus 1 plus x minus 1. All right? X plus 1 is the outside times the whole, x plus 1 plus x minus 1. Whew. All right, so let's clean this thing up. In here, we'll get 3 times x plus 5. And over here, we have x plus 1 times, look at this, the positive 1 and the negative 1 will cancel, and we're left with 2x, which is nice because we can just distribute that in. All right, so over here, I get 3x plus 15 equals, it's still a little bit backwards, but it's okay. 2x times x is 2x squared, and 2x times 1 is 2x. Yikes, we see that x squared. So this is going to be one that we have to make set equal to 0 and solve by factoring. All right, hopefully you remember that from the packet we did right when we went to remote learning, but let's review right here. All right, I need to bring everything to one side and set it equal to 0. So I'm going to go ahead and bring everything over here since I've already got most of it there. And I'm going to subtract 15 and subtract 15. Okay, I'm kind of doing that all in one step. So I end up with 0 equals 2x squared minus x minus 15. And here's where we have to factor. So 0 equals, remember I put a 2x and an x. Remember this? And you have to figure out what multiplies to give me a negative 15 that will add to give me a negative 1. And so you can kind of guess and check, and you'd come up with 5 and 3. 2x times 3 will be 6. 5 times x will be 5x, 6x and 5x. And so I need that to be negative and that to be positive. All right, let's erase those marks. And then I just set each of those equal to 0. So 0 is going to equal 2x plus 5, and 0 is going to equal x minus 3, and we solve for the variable. So what happens here is x ends up being a negative 5 over 2, and this ends up being x equals 3. All right, so a negative 5 over 2 as a decimal would be a negative 2.5. That might be easier to see that if I plug a negative 2.5 into here, it's going to make that segment negative. That can't happen. So we can get rid of that guy. And the answer is x equals 3. All right, good job.